Finally, we're in chapter 10, the last chapter of this semester, acids, bases, and salts. The definition of acid base has evolved a few times in scientific history. The most original one is the Arrhenius acid base. An Arrhenius acid is defined as a hydrogen-containing compound that produces hydrogen ions in water. Why is it defined this way? The word acid means sour. So why do they define sour or acid in this way? Well, this is the difference between a scientist and regular people. For us, we taste something sour. Okay, that's sour. You like it, you eat them later again. You don't like it, you don't touch them in the future. That's it. But scientists think they think things in a different way. When they taste something sour, they want to figure out what is inside, what is making the substance sour. So they started researching on them, taking different sour substances and try to figure out what is in common for them. And eventually, they realized that one thing in common for all of them is that they have hydrogen ions in the water solution. So the hydrogen ions in the solution causes the sour taste. So they define acid in this way. For example, nitric acid, if you dissolve in water, it produces hydrogen ions. Hydrogen ions are also called protons. A hydrogen ion is also called a proton because hydrogen has only one proton in its nucleus, has only one electron. Once the electron is lost, what is left in the hydrogen ion is only a proton in the nucleus. That's it. So a hydrogen ion is also called a proton. So when you dissolve nitric acid in water, it produces a proton and a nitrate ion in solution. That is an Arrhenius acid. Well, Arrhenius base, once they defined Arrhenius acid, well, at the same time, they also know that there are certain substances, if you mix them with acid, the sour taste will disappear. The taste will be brought back to a basic taste. There is no taste anymore. They define those kind of substances as base, and they realize that basic compounds, Arrhenius base, is a compound that contains hydroxide ion. Okay, that substance contains hydroxide containing compound that produces hydroxide ions in water solution. Sodium hydroxide dissolved in water, it produces sodium ion and hydroxide ion. That is a base. Well, let's look at these two processes again. The process of ion generating from an acid and ion generating from a base. In the first of all, both processes do generate ions in water solution. This is something common for them. The difference is here. For Arrhenius acid, the original Arrhenius acid is a covalent compound. How do you know it's a covalent compound? Because all the elements in it are nonmetals. All Arrhenius acids are covalent compounds. So in the first process, ions are generated from a covalent compound. A covalent compound has no ion in its molecule. It's a molecule. So ions in the first process, ions are produced from a compound that has no ion before. In order to produce ion, you have to ionize it. A covalent compound, a covalent Arrhenius acid, is ionized in water to produce ions. In the second process, ions are produced from sodium hydroxide. Sodium hydroxide is an ionic compound. It has a metal and has a polyatomic ion. We know that it is an ionic compound, which means whether you dissolve it in water or not, there are ions in it. Even if you don't dissolve in water, there are still ions in the solid state of sodium hydroxide. When you dissolve it in water, ions are not generated. Ions are just dissociated from the original form when they're staying together. Now they are dissociated into individual ions to stay in the solution. So the two processes are different. We call them ionization and dissociation. When ions are produced from a covalent compound, that is ionization. When ions are dissociated from an ionic compound, that is called dissociation. So ionization. Ionization is a process in which individual positive and negative ions are produced from a molecular compound. Well, in the case of ionization, all situations we see in this class, it is going to be Arrhenius acids. And here is an example. Can we have another example? Of course, any Arrhenius acid. Let's say hydrogen chloride. If you dissolve in water, you're going to produce a proton and a chloride ions. That is ionization. Dissociation. Dissociation is a process in which individual ions are released from an ionic compound when it is dissolved in water. Well, the example we had on the last slide was sodium hydroxide and Arrhenius base. However, some other kind of compounds can also have dissociation process, like salts. What are salts? We don't know yet. We're going to talk about that later. Majority of the ionic compounds are salts. Here I have a couple examples. This is the first example that we saw on a couple slides before. Arrhenius base. I have another example here, potassium chloride. Potassium chloride is a salt. When you dissolve it in water, they would dissociate. They would dissociate into potassium ion and chloride ion. That is dissociation. A drawing to show the difference between an ionization and dissociation. Okay, the first one, we have an Arrhenius acid here. They are covalently bound together. There's no ions in its original molecule. Once it is dissolved in water, they are ionized into individual ions. Dissociation, right now it is using an Arrhenius base as an example. Again, a salt, when it is dissolved in water, the process is also dissociation. So we have a metal ion, a positive ion, and a negative ion in the substance itself, even before it is dissolved in water. There are ions in it. Once it is dissolved in water, the ions dissociate into individual ions. Practice. Classify each of the following processes as ionization, dissociation. All right. When you see questions like this, you need to look at original starting compound. Your decision to make is that compound an ionic or covalent? If that one is ionic, dissociation. If it is covalent, ionization. Well, clearly potassium hydroxide, an Arrhenius base, ionic compound. Dissociation, carbonic acid, Arrhenius acid, ionization. Copper-2 sulfate, ionic compounds. You have metal, you have polyatomic ions. So that is an ionic compound. Dissociation. Some more facts about acids and bases. Acids have a sour taste, we know that. Well, acids will change a blue litmus paper to red. Litmus is a kind of dye. Okay, it changes colors when it gets into contact with acid or base. So a blue litmus paper will change to red when it gets into contact with acid. Acids are usually corrosive to many materials. A base have a bitter taste. A base will change the red litmus paper to blue, and here we have a picture shows you an acid changes the blue paper to red, and a base changes red paper to blue. Okay. In the lab, you're going to use these papers to test whether a solution is acid or base. See you next time.